theory, I am now streaming to your channel.
All right, I'm watching the channel and I don't see it.
Customer TMP.
Let me go straight. All right, I see it.
All right, so that's working. I'm not seeing it yet.
There's
always a delay.
Oh, there it goes.
Now I see it.
Yes, you are.
Now I see it. And I'm not hearing yet, but let me see if I hear us echoing.
Yeah, I'm closing the.
Yep.
It will echo otherwise.
Okay, I'm closing that
right,
so I don't get
stop
echo.
Sharing my screen.
That's working. What's the deal with the chat widget there? So that's working. I just need to, but I'm having bandwidth issues again, still. You keep dropping out on me.
Nope.
Now it's clear. I think it takes a bit. Yeah, I can hear you now. Okay, you were dropping out a lot there. I think it takes 30 seconds or a minute for XSplit to settle down and figure out how it's using the CPU and system resources, right?
I've never heard of a macro event 1 minute in duration for leveling a processor.
No, I know. But that's how long it takes.
It was a nice try, but
Good news is it's using my GPU, and so far so good. Like it took a minute, but now I'm getting you pretty consistently.
Right. Well, I'm going to try and broadcast to Facebook. Oh no, I can't. I'll lock up my. I learned that just. Yes, we continue to have problems with XSplit. I tried to stream to Facebook and it locked up XSplit.
Hey, you know what you could do there, Bill?
What's that?
Or maybe I could do it. I could put the Discord up in the corner there on my XSplit, so the chat, we can use Discord to chat. Well, I don't know. What do you think? No one's going to be in Discord. Only 3 of us are in Discord so far. So we'll still use the live.
Actually, if they go to CoriolisEffect.com, they can find the Discord channel. Let me grab the Discord here if I can remember how to.
Oh, and I closed my browser before.
CoriolisEffect.com, Discord.
I just realized too, I closed Opera before I'd posted onto LinkedIn and Twitter. So I'm reopening it now, and it's going to kill performance for a second here.
All right, here's Discord, but I doubt they'll be able to read it.
Well, remember, I'm streaming, so we're looking at our Skype call and my screen right now, and your Skype call is sending me the chat from YouTube with that widget.
Right.
So how do you get that widget set up?
Widgets. All right, so I'm seeing the chat, I'm seeing it on the web page. So apparently Unix has joined us, an entire operating system family.
I love it.
Chris found the real stream. No, Chris, we were switching streams. We continue to have problems.
Man, this is slow.
We have all new problems every time. I've never seen a system that creates new problems every time you use it. It's like a chaos generator.
Yeah, it takes some skill to do that.
It does. It does. Especially, you know, having seen so many issues myself over the time. for it to create all new problems. That's dynamic. It's gonna make me cynical in a minute.
Like you never were.
Nah, not me.
This is the problem when you configure your browser to pick up where you're left off. I shut it down to save system resources, but then realized I hadn't posted to LinkedIn or Twitter yet, so I have to open it up again, and guess what? It's loading all the tabs. All, I don't know.
Yeah, somebody
80,
just made a comment. And,
all 80 of them.
And yeah.
On 2 screens.
At one time, they were firing up an individual process for each tab. So it wasn't 10 tabs in one process. It was 10 processes. It was just horrible.
Yeah.
Hey, Mike. YouTube is amazingly flaky. Yeah, I thought it had a good reputation, but we literally, right now, I'm blaming XSplit's plugin for YouTube on my end. So I upgraded because I had to do a Hackaday video, and Ben hasn't, so that's why Ben's is still working. Bring back Mbone. Multicast Backbone of America. Mbone. I haven't heard that in years. I was an ISP starting in '95 to about 2003, so or 2013. So Mbone was a real thing back then. Never used it, but it was a real thing.
That's right up your alley with the wide area networking stuff there, Bill.
Yeah, multicast, yeah.
Man, these are taking so long.
Oh, somebody said my audio, it sounds like it's breaking up, and that's probably due to just, we got too many things going on here.
Yep. We're still early. Oh, no, we're not. We're 1 minute overdue. But I'm posting on LinkedIn because it's important. I had a little quip as well. It had a rhyme to it, and I've lost it. Dang it.
Yeah, Mike used to work at UNet, which was one of my first, they were my second backbone provider. AS701, Autonomous System 701 is UNet.
And this week we finally also got, it's the best tool ever invented. What is it, Bill?
Screwdriver.
Around to it. Everyone's got to get around to it.
There's a square peg joke in there somewhere, but I'm just not feeling it.
Yeah, there's probably other jokes too that are not appropriate for children.
I'm waiting for either YouTube or the XSplit to screw us yet. The imminent screwing is on its way.
Okay, YouTube stream is the link. Discord server. What was the Discord link? It's there on the Coriolis Effect website.
Coriolis-effect.com. You have to learn how to spell Coriolis, or at least I did. You knew how. I didn't know how.
I didn't at first. It's spelled with an O, which we normally say Coriolis or Coriolis.
Say it with an A.
Yeah, but it's Coriolis.
And now it sounds like I'm a recording when I try and say it. It's like Coriolis. In fact.
Now that website you set up for us, Bill, thanks for doing that. That's just a WordPress site, so we can actually post short blogs about what we do in each episode, right? In future.
We could if we get this working, but I have yet to see it working. They're saying my audio's crap. Well, crap's my word, but twice somebody said something's wrong with my audio.
It's weird. It sounds good to me, but I'm getting you through Skype. But they should be hearing you through my XSplit through Skype. But to me, in my ears, you sound good, so I don't get it.
Highlight me and right-click and make sure my speaker is unclicked.
Was someone complaining about echo?
No, but just in case. So
it's set to stream only, which is what it needs to be.
Okay.
Okay, now I'm just posting to Twitter real quick, and then we'll get going with the show. And then I'll kill my Opera browser, and it's 85 tabs. Twitter character limitations.
Yeah, they're saying my audio's crap would be putting it nicely. So the Cylon effect was originally a vocoder, one of the coolest uses of the vocoder, I felt.
That's right, and there was an electronics kit sold in Australia. It was done through Silicon Chip magazine that had that same sound, and it was called Vader Voice. It was a little bit different, actually. It was more of a chopper.
Right. Yeah, but a vocoder is where you basically try to determine the fundamental frequency, set up a tracking oscillator, and then replace inside the audio envelope, replace the original content with an oscillator. Am I
That's
remembering that?
That is one implementation of a vocoder which is used in speech synthesis for cellular communication. So a lot of regular people, our audience would know this probably, but a lot of regular people don't know that when you're hearing somebody's voice on your cell phone, you're not actually hearing their voice sample. The way that compression works for cellular networks is exactly what you described. It's called linear predictive coding. There's an algorithm that analyzes the frequency content of the speaker's voice and makes it a frequency envelope in usually 10 bands, but if you want higher bandwidth, you need to use more bands to get more detail. But it's like it constructs the frequency content envelope, and that gets compressed and sent to the other end along with a fundamental frequency of a pulse source. So the phone at the receiving end does pulses at the pitch frequency and then puts it through a filter that gives it the formant characteristics that were detected or measured on the transmitting phone. And there's almost all voice compression algorithms are based on that fundamental process, and some have more detail and fidelity than others. But that's essentially how it works, linear predictive coding. And the vocoders that came around in the 70s that were done in analog synthesizers. We didn't
have a lot to choose from. Yes.
Yeah, that wasn't it a Roland? Roland, I think, came out with one first that had a microphone input on the synthesizer, and it did it all analog. But it would take your voice and use your voice as a
sound source for the envelope. Yeah.
Yeah, it would use your voice for generating the envelope and the filter bands, but then apply as
whatever key you pressed.
Yeah, the fundamental. That's right. The actual synthesizer became the source of was the oscillator.
Modulated waveform.
Yeah.
Yes.
So you get the synth sound, but with a voice pitch sort of formant characteristic over it. It's very cool.
Right.
Very cool.
Well, that was my first electronics design, because I repaired things since I was like 13. But my first design was a monophonic synthesizer, what they call synth these days. And I had tracking filters and Leslie effects and everything all built into it. And the one thing I wouldn't do is put a regular keyboard on it. Since I didn't play the keyboard, I didn't want somebody to play my synthesizer better than me. So I made up my own keyboard with calculator keys.
That's cool. Oh, with you can play a tune, but like with a numerical keypad.
I made it my hand, so by dropping your hand downwards, you were going down an octave, so it'd be an octave, an octave, an octave. So it was like touch typing, only instead of going right and left for up and down in the octaves, I went straight away from me or towards me. So, yep, Bill's voice is hanging. Yeah, if what can we do to fix the voice?
What was the comment there?
They said it's hanging.
Like getting stuck?
I was getting, yeah. You closed Opera, right?
I did. I'm sorry. I'm hoping that by reducing other applications on the system that it.
Now I lost you. This is not working. I've lost you.
I can still hear you fine.
All right, you're back.
Yeah, it's just the Skype call bandwidth is obviously not that great. I guess this is the beginning of the end, and we're waiting for FEMA camps to open, right?
Yeah.
Anyway.
Somebody's making a +4 joke here. So, since I can't talk very well, you want to show us, did you manage to pull up the Quooks example?
Oh my gosh.
Oh, sorry, I didn't mean to spring it on you.
Yeah, you do this, but this is what it's about, right? You spring Quooks on me every time.
Well, I've been advertising it for 4 weeks now.
Well, we talked about it last week and the week before.
Well, I guess we did. Yeah, no, I guess I was just wanting to see the physical PC board samples get into the model. You're right, we did talk about it. My apologies. Don't ever lose your short-term memory. It sucks.
Well, actually, I made an.
Have I said that before? I forget.
I made an interesting discovery about Cook Studio this week while playing around with it, and I wondered how are they doing the FDTD simulation. So let's open it up, and I realized actually they bundled OpenEMS with it. So OpenEMS is a free finite difference time domain simulation engine that was written by a chap in Germany. It's open source and it works with MATLAB and it works with GNU Octave.
All right.
And you normally use it with Octave and you write Octave scripts to drive it. So it's a programming based interface to generate the structure. The nice thing about it is he developed a tool along with it that translates an Eagle PCB file. Now it won't easily simulate a full-on design, but if you just want to get an idea about a specific microwave structure, you can design that in a PCB layout in Eagle.
Right.
Export that and bring it into Cooks. Bring it into OpenEMS. But Cooks had the nice UI for defining a structure, right? So we're looking at that here, and I'm not really good at it yet. The channel, the person who published this has a channel that he walks through an example, but I had something, let's see, where was it?
So just for everybody to know, it's not my bandwidth that's the problem today.
No,
a couple times somebody said that.
It's not, because I'm hearing you and seeing you just fine. Your video locks up occasionally, but I've had no trouble getting your audio. So it's probably from my house out to the interwebs, but I'm not sure.
Yeah, it's going into bends. What we're doing is we're relaying through bends today because my software still has issues. We verified that it's not just operator headspace, in other words, me, and yet, so we're bouncing the signal over to Ben for him to transmit to my account. As stupid as that sounds, this is why I hate programmers. No, I like some programmers, but this is why programmers need to be shown a little fear every now and then, right? Otherwise, they write code that you try and use, and geez, Hey, so I got new hardware. Actually, it's old hardware, but it actually just came in. I've been talking with Mike about the old radar thing. So I just shot a new radar board in 6-layer. But what this reminds me of is the tariff exemption just ran out for printed circuit boards. So if you're buying your PCBs overseas, you're going to pay a little bit more for 4-layer, 6-layer boards. I don't know about 2-layer boards.
Who's imposing the tariff? Is it the US government?
U.S., the U.S. government, yeah. So it was exempt for a while, and now it stopped being exempt.
Do you know what the tariff is, by chance, percentage-wise, or?
No, I don't, but I plan on learning my next PC board purchase.
So,
but it won't be a lot.
Right? It won't be a lot, but if it's a massive issue, you're probably, going to be going with a local fab anyway, because that's the whole idea, right? Now, we have listeners here from everywhere in the globe. I think there might be similar things in Europe, but I know every continent now pretty much has really good low-cost prototyping services available. And yeah, here in the States, it's still a bit more expensive, but you get it a lot faster.
It's still the old model a lot of times,
Well, unless you're going to Osh Park or Macro Fab or some of these places that they've really looked at cost optimizing as much as possible. But the benefit is,
but you pay for it with delay. Then it's like you pay for some way or the other. And even Osh Park is in the U.S. I think Drew said.
Yeah, they're up in Oregon, and I don't know where they're.
Yeah, I mean their fab is in U.S.
It is.
Yeah, because. Originally, and I'm going way back, I think they were using Phoenix Gold, but I got corrected on that, and they've been US-based for a long time now.
There's no other way they could get you the boards within 2 weeks like they do. And I love that. I'd rather pay a bit more and have them in my hot little hands while I'm ready to actually build the thing,
Right, and that's kind of what I do as a quick turn service. So up until now, oh, by the way, it's also the New Year season over there, so there's going to be delays this time of year
that's
also.
True. Chinese New Year.
Yep.
Or Lunar New Year, let's say, because it's not just China. There's some other Asian countries that have that too.
You're absolutely right. And I didn't say Asian either because I didn't know the subset that did, so I just went to the New Year thing. But yeah, the Lunar New Year. That's right.
I'll show you what I've been busy with this week.
Yes,
real quick.
Show us a project.
So I'm finally getting my chops on this, which is cool. I spent a lot of time modeling parts. And again, this is not a complex design. You can see it's all through hole and discrete. It's actually, this is what I showed last week, the octave up guitar effect. But I've been wanting to build one of these for myself for years, and finally used this as an excuse or a reason.
Can you make that a full screen?
Oh yeah, I'm sorry.
Just drag the corner. Yep. That's what I was doing, is I was just dragging them dynamically rather than keep programming them and blow the audio.
Yeah, so this is the board layout. Simple 2-layer board.
Yeah, I see what they're talking about. I might as well not even be on this call.
Really?
I'm just locking up in the feed. Yeah.
I don't get it.
Well, it's not taking the call, turning it around, and sending it out in an optimized way. I don't know what that is, but.
Huh.
Yeah, I look all grainy and just. All right, so keep talking now.
I'm just showing.
Cool, very cool.
Yeah,
I love
the rendering is really amazing here. This is updating it because I've actually done some editing since. So you'll see there's a little status bar in the corner. So it takes a little while because I keep chipping away at my library, adding better, more realistic models.
Now, do you have the ability to make the color bands on the resistors reflect their values?
No, that would be icing on the cake, though, wouldn't it?
Proteus can do that.
Yeah, even Protel 99 SE could do that in the old 3D renderer, but since the support of step models and the integrated 3D in the PCB design, that capability was never implemented because it was just seen as unnecessary. But my personal opinion is I would like to parameterize every 3D model of every component. Wow, why did I zoom right out there? Let me zoom back in. I'd like to parameterize them and actually have I would like to have them reflect the actual values, or the because one thing I can do in Fusion is I can build the models and add decals to them. It's not called a decal. What's it called? Maybe it is called a decal. I don't remember. But I can take a flat 2D image and wrap it around the surface of some part. So I could have text. I could have colors. And yeah, there's no reason why the text shouldn't be able to point to a parameter somewhere. But that's way down on the list of priorities. There's a lot of other things I want to fix.
That's just eye candy.
But it would be cool. It would be useful. I'll tell you where it would be useful, because Fusion's all about this. It's all about not just design, but manufacturing. And one of the things you need to do when you're tooling up your assembly line is set up optical inspection. And so conceivably, we could use this rendering workspace with the component values printed on them and generate a reference image in 2D and 3D that the AOI machines could actually use as a source, even for the initial production run, to say, yes, this has been assembled correctly, or no, it hasn't. But of course, chip resistors, you don't have color bands, but you certainly do have text, unless they're smaller than 0603, then they're. I think 0401, 0402s have text printed on them. Depends on the manufacturer. Much smaller than that, you don't. Right. But that's cool, because I like this, because I can assign material properties to all these things, and even my diodes, you can see I made them with actual glass. One thing that
now is the jumper. Do you have a jumper on a post header, and the jumper is on the build? How did you do the jumper that I saw?
Actually, I'm just using these as connectors that I would solder wires onto to go off to switches.
Right, but then one of them looked like it had one of the jumpers on the post header. Was I seeing that?
Not on this design, no. Yeah, that was probably one of these transistor
those
bodies.
Must be little caps then. Yeah, okay. I thought they were jumpers. Show us the diode then. I didn't mean to derail you there.
That's all right. This is the diode model. Now in the library, it actually has a decal for a cathode band showing on it, but there's a display issue in the main workspace here where that. Same with these capacitors. I did put a negative stripe down one side, and they're not showing up in the main workspace. They do appear in the library. I'm hoping that when I do proper rendering that the decals show up properly, but we'll see. Something else I like is the way the printing of the silkscreen actually looks pretty realistic to what it would look like from a real silkscreen. Where it's these days, they're not actually screen printed sometimes, unless it's mass produced boards. They're inkjet printed.
Inkjets, yes.
So that's what I've been doing this week, and I'm actually quite proud of the result. I think it looks awesome, and the cool thing about that is I have the full assembly. So let's reopen my data panel so I can show you that too. I have to go back to my home.
How good is the library management? Are the parts you're making? Are you making your parts that you'll have forever and other people can use? Right.
My library is my library. So all these parts I'm making are in my folder, and I can choose to share them with others if I want to, but I don't have to. Right. There is a central library that Fusion and Eagle users can both access called library.io, and similarly you can build your own library parts and either choose to share them or not. But there's also a few 100,000 parts in there that are just like the default set you get with the tool, and everyone gets those.
And by sharing, I tend to think of sharing inside a company. I don't think of usually sharing with lots of people, but inside a company, you would want to not have two people making the same part.
Right.
One, you'll get two different parts, even slightly different.
Yeah, that's right. So this whole thing, this is telling me, because this is an earlier version before I placed all the parts and routed the board. So it's just telling me I need to update that. So I'm going to go get latest version.
And this has integral version control in it?
Yeah, it's built like everything is version controlled in WIP. And so you can go back. If you make a mistake, you can restore or elevate a previous version, or promote is probably the right word, and down to that ability to, and they're automatically checked in and everything. So.
And you said this was a stomp pedal or an effects pedal, an effects box?
It is. That's really strange, because that's not actually the right. Not everything's in the right spot. I don't know why. It did allow me to modify the enclosure, though, to put all the appropriate holes and cutouts in it.
Yeah, it looks like it flipped the parts 180. They're actually still lined up with the board, it looked like.
Yeah. Oh, and it might also be because this has been updated and I haven't saved it yet. Let me save.
Yeah, don't ruin your work because you're showing us.
It's all right. No, this is all good, and the PCB layout's all good and fully routed and everything. I'm not quite. I'm just doing final DRCs, and then I'll send it off to Oshpark or somewhere to get it made. So in a future video, we can actually listen to it.
How good are the DRCs that come with it? Because a good DRC set can make or break you, is my opinion.
It can.
My experience.
The problem with anything default in any PCB tool is it's the lowest common denominator, right? So having said that, the default rule set is reasonable, especially if you're doing basic low cost boards. So the default clearance, for example, is 6 mil. Default minimum trace width is 6, and 6 and 6 was cutting edge 10 years ago, but today it's anyone can build those with good yield. So it's cheap and still gives you plenty of routing space, and you can do any kind of surface mount PQFPs and QFNs with 6 mils trace and space. And for obviously this is entirely through hole. It's intended to be handmade in my shed, and then maybe I'll share it online and people I'll open source my board or something. I don't know. I haven't decided yet, but
somebody did mention that you can alternate the side the leads are on for the resistors, probably to reduce the chance of shorts.
I can, yeah. I've rotated these purely for signal. Like for optimizing the routing, for making the routing easy. But my 3D model is obviously one-sided, so I can pin swap and move them around, but I'll just do it while I'm assembling it. I'll choose as I go which way I bend them.
Right.
But yeah, that's a good point.
So actually, it's a DFS. It's designed for shed.
Design, yeah,
set of rules,
and because it's
for your hand assembly.
I like this. It's not only designed for shed, it's also a guitar distortion unit, so it's also designed for shred. That's an engineering musician. That's an engineering musician dad joke. That's like the trifecta right there. My kids would roll their eyes.
Right. I was going to say, outside the door, they're rolling their eyes as we speak.
So this is detected an update again. So let me do that, and hopefully it fixes it. I find it interesting that the PCB looks exactly correct, but all the parts are in the wrong spot. That's weird. Let's see what it does.
It's the auto parts placement.
Yeah, I think I've on a live stream in front of everyone, discovered a bug that I need to go back to our developers with, but we'll see. It's still updating, so yeah, there's definitely a bug there.
So, so I mentioned auto parts placement, which I've used to help tell me if the board is going to be big enough, but I've never really used unless you constrain the heck out of it.
Wait, you've got an auto parts placer?
Well, Altium does, and Proteus does also.
Altium doesn't. It doesn't.
Yeah,
it used to. It had a menu item on the tools menu for auto place, and it did nothing. Literally, actually, for about, hopefully I don't get in trouble for saying this, but it's actually factual truth, and any user digging into the tool would discover this. The auto placer design rules and the auto placer command were stripped out of Altium Designer some time ago because they could never get it to work well. But they left the command and the rules in there and didn't say anything. So you can fill them out,
what I see.
And you can click the command and it will do nothing. It'll just, it's a dummy command. It literally just returns and does nothing.
So where was
Altium, well, since version 18, when they did the UI update, that command was finally removed. But 17 and earlier, you'll see it there in the tools menu in the PCB editor, but it does nothing. You'd have to go all the way back to probably Protel 2004 to see it try to do anything, and it makes a mess.
Oh, yeah, I never said it didn't make a mess, but where I was headed with that was the last time I used a spreadsheet to predict parts usage, parts placement. Will it fit on the board is the question. And a good old spreadsheet answered the question. I mean, right down to it fit, and it didn't have extra room, but it didn't not fit either. So that's still a technique I use, is for each dip or each SMT package, it's that package plus a little more area, and it works most of the time.
That's good to know.
So, but yeah, before that, I used to use the auto placer just to like go, well, can you get it all on the board? Okay, can you get it in this corner? Okay, and constrain it and go through several iterations, but then tear it out and then manually place things.
You know what really blows my mind, Bill, is like for years, place and route automation in the semiconductor tools has worked just fine. Why do the same algorithms, or maybe they're not the same? Maybe that's the problem. How come we can't get an auto placer to work on PCB? Because I haven't seen one yet that actually does a reasonable job.
Would it do a reasonable job on a 20-layer board? Because the chip is essentially 20-layer or whatever number they're up to these days, but they just got millions of metal layers.
Well, that's true, but that's for routing. And I guess place and route, we lump those together in chip tools. It's always called place and route, right? But the placement of the cells, the placement of the parts or macros, really the components, we ought to be able to do that in PCB. I just don't know why no one's really been able to nut that one out.
I assumed that it was the people in the industry telling the CAD developers that you can make one if you want, but I still won't use it.
Maybe.
And I, for one, would use it.
Maybe.
If you made a good one, I would use it and then adapt it. However, but if you made a good one, I'd use it because I do rapid turn stuff right now. I'm not doing true design for manufacturing with full signal integrity and stuff.
Yeah. I know. I would at least use it to get the initial placement, and then what you do is you go in and tweak it, right? And you rotate things and
yeah. So Mike asked if transmission line effects come into play inside a chip. So I know my answer, but I'd like to hear your answer.
Depends on the frequency. I mean, they always do, but it comes down to that. Are you dealing with lengths of signal paths that are greater than 1/20th of a wavelength of your signal?
1/20th or a quarter?
A 20th. A quarter.
Okay.
By the time you're at a quarter wavelength, you've got a whole other kettle of fish. That's actually
Yes, you
where
do.
you're doing transmission line structures for filters and stubs and all of that. Those are all around the quarter wavelength size. But when you have to pay attention to reflections and transmission line effects and impedance matching, is at about a 20th of a wavelength.
Right. So I know a chip guy I can ask, but my answer would have been, no, it's all about the quantum tunneling effect at those. At real small, when we get down small, we kind of throw away the effects of fields and we go back to the effects of electrons. It's the way I look at it. I could be wrong.
Well, that's above my knowledge level and pay grade. But yeah. See, you've studied quantum mechanics. I haven't.
So you showed a display a little bit ago. You want to show that again?
Oh yeah. This is just a bit of this. This is the what's on your desk question part that Bill was asking me. I was fooling around with these WinStar OLEDs. This demo board they gave to me at the Del Mar Electronics Fair quite some time ago. I want to say 10 years ago, right? But it's the same driver chip, and I'm working on another design that's got to have a daylight readable display. And I purchased a couple of samples of the bright daylight readable blue one. And luckily, I don't have to wait for my own prototype to test them because they happen to use the same connection pinout and controller chip. So I'm just popping this onto the flex connector. Whoop.
So while you're doing that, yep. I had pulled out my display that just I found 2 days ago. I had built a single board 6502 right before the pandemic hit, and this was to show that I could run a 20 megahertz 6502. And so I had a vacuum fluorescent display to go. That's cool. That's a nice color on that.
It's really high contrast. And you can see because my camera is at a different refresh rate, so it's flickering a bit, but it's really, really nice.
Well, you can read it right through the reflection off of it. I can see your window, or actually your circular light.
Yep.
And you can still see the wording through
it. They're very nice. They're very expensive, OLEDs. How much do you think I paid for these samples? I got 2 of them. They were $30 each.
$40.
They were $30 each for 2.
I was guessing 40.
Yeah,
okay.
So not far off.
Yeah. So what I was showing was a vacuum fluorescent version of the little 2-line by 16 character.
Yep.
And I was going to put it with the single board computer just for that nostalgia's sake, right? Because I was like, I need some kind of display. So, let's go with vacuum fluorescent. But otherwise, it's that same footprint you see everybody using for 2x16s, 2x20s.
Now, what's the power requirement on those? Because they chew a bit more.
I was going to say it's got a little switching regulator, and it creates its own high voltage all on the board.
Yep. But how much?
And I know there's a switching regulator because there's a coil. I mean, that's what we look for.
Because they need to step up. They need like at least 60 volts because it's a vacuum tube.
Right.
It's actually a triode. Yeah, it's a triode.
Yeah,
and the cathode has phosphor on it that lights up when the electrons hit it.
The cathode has phosphor.
The cathode. The anode is the heater.
Anode's
the heater wire over the top. Yep, there's a heater wire over the top, so that has to be biased up to 60 volts, and it gets about 5 volts to heat it up. So you need a secondary that is floating. So you need a little transformer normally. This is how we used to do it. I used to service TTYs that had vacuum fluorescent displays. They had these little self-resonant step-up converters in them that would get they'd get really hot, They'd be ringing all over the place. Like, there's no way they'd be allowed to do them today. There's no way they'd pass EMI regulations. But
right. And I had done a design that had several different size vacuum fluorescents, and I wanted to drive them all from the same 80-volt supply, whatever. So what I did was I took the outputs of transformers and I just took their center taps and I made them go to various voltages so that one would think it was biased off 60 and the other 80, and meanwhile the center taps are 20 volts apart. So I found a way to isolate them and still drive them from the same column and row drivers.
oh, that's cool.
Because it was all about multiplexing, but I didn't want to have one multiplexer for one size and one for the other, so I multiplexed everything from one set and just changed the center taps. So yeah, it was kind of something I never read about, but it kind of made sense and it actually worked.
So where do you get VFDs? Because they've become trendy lately, and it seems like
DigiKey.
the price is even on AliExpress. Like, you used to be able to buy character and figure 8 multiplexed VFDs dirt cheap because they were old stock products that had long since been superseded. And there was a period there where no one wanted them. And now suddenly, because, a few magazines publish hobbyist articles where they're building VFD Nixie tube clocks, because, of course, we ran out of the
Right.
neon Nixie tubes. So now we've got the VFD versions as well. And suddenly anything VFD is horrendously expensive, even if I'm shopping on AliExpress.
Right.
I acknowledge that
So, yeah,
they're
it made
hard
me
to
think
make.
of
They do cost money to make. Anything with a vacuum in it made of glass is expensive. So
Right, and then you got there's one of my leftover Nixie tubes from years ago. It's the Russian one, probably. No, it's written in English.
I should have brought them in out of my shed, but maybe another episode I'll talk about triads. I've got a couple of boxes of triads for audio and guitar stuff, but the cool thing about the collection I have is most of them were actually made in Australia by AWA back when the globe, all around the world, every major continent had its own tube manufacturing companies to
Sure.
support the electronics industry.
Yeah, my dad worked for RCA. My dad was a ceramic engineer for RCA making picture tubes. So literally a vacuum and getter and the anode P2 button was part of what we talked about at dinner at home,
Cool. It's cool stuff.
So,
So they're nostalgic. I think most of them are in brand new condition. And my intent was to use them in guitar preamps. But now I'm doing everything
So let's
digitally.
talk- right. So you mentioned triodes, which aren't real common in tube gear for a reason, but they're useful in audio preamps for a reason. You want to talk about that real quick?
They're almost entirely used for audio preamps. I don't know if
RF preamps too.
are they?
Yeah.
Okay. Well, they're the
Yeah.
simplest
And-
device, and they're the most easy to design around. I think that's probably why. I don't know enough. I don't know enough about
I
valve
was taught
theory.
they had less noise. That with the less screen grid. So what we have in a
Probably.
triode is a simple gate, anode, and cathode. And then when you get to a pentode, you've added a screen. I'm going to forget all the elements, but I used to know the elements. So they can make it more linear in a pentode, but it's got more noise. That's what I was taught.
Yes, and pentodes for the linearity are used in the power amps, especially
Yes.
most of them are push-pull through a transformer, and most of the linearity, apart from clipping, comes from the magnetics of the transformer.
Right. And then what you'll see is negative feedback come from the transformer. They'll go and throw a little tap on the transformer, bring it back and put it as negative feedback. So our earliest, before op amp, well, they used to make op amps out of tubes, but we were doing negative feedback in the audio
That's right.
amps
Were they
years ago.
They were called fill brick, weren't they? The op amps made of tubes were called fill brick op amps, and they had two twin triodes, like two 12AX7s or two 12AU7s.
Yeah.
So they had four triodes in total, two for a long tail differential pair input stage, one gain stage, and one output. I keep saying emitter follower, but it's a cathode follower.
Cathode follower, right? Yeah. So in my old tube book, they still show you how to use tubes.
Yeah, that's awesome.
So right in there, they tell you what grid leak bias is and all the different discriminator circuits.
Grid leak.
Here's how to make them.
Yeah, grid leak bias is why you put a resistor in series, or you put a resistor. Yeah, you put a resistor in series with the grid. In the preamp, it helps.
And it develops a negative voltage on its own.
Yes, and it helps.
It's kind of like a Venturi effect for electrons, is the way I always picture it.
Oh, wow, yeah.
It developed it by the electrons being swept along to the cathode, along with others, and it'd be about 7-8 volts negative you could develop.
Yeah. Yeah. So good guitar preamps even have a grid stopper or grid leak resistor. You don't have to do it, but they improve performance.
Right. So, and then of course I'm from the days when picture tubes were round when I first started.
I can't imagine the pain of looking at those.
Especially the old Zenith.
Yeah, that like a bubbly rounded rectangle that was only this big.
Right. Then they put a thing on it to make it look rectangular, but it's still a round tube behind it, and you lose everything in the corners. So we used to chuck them off the bridge over the railroad tracks.
Bad boy.
And one time the police came to see what we were doing, and being very tactical, we turned around and acted like we were walking towards the source of the whoomp, and got away with it the one time they looked for us. Yeah, you do it at night, you'll actually get a flash of the phosphor.
Oh, I didn't know that.
Unfortunately I do. So, meaning, yes, I have thrown a picture tube at night, or thrown a brick through one. But I used to have all the kids in my hometown bring me all the chassis they could find throughout the town. And so I'd end up with a couple spare picture tubes too. So we did have to find a way to dispose of them in an artful way.
So,
one for you. I was telling somebody that this is a heat shield off a Commodore 128.
Heat shield.
And I was telling them that, yeah, it's an EMI shield that has heat sink tabs. Matter of fact, you can see the bird shit on my fingers. So yeah, so the chips wouldn't have needed a heat sink until we put the shield on. So we made the shield back into a heat sink, but it's got huge gaps in it. But that's why I was telling somebody is those gaps are math. The diameter of that hole, has math behind it. The spacing of the holes has a little more art than math, but maybe some math behind it.
Yep.
So it's aperture.
That's right. They won't shield.
See your.
Yeah.
Go ahead.
No, they won't shield millimeter wave, but.
No.
But they'll keep pretty much everything else in.
Yeah, we only went up to 350 meg in FCC scans back then.
I'm surprised that the chips actually needed a heatsink.
They only did because we created a closed air area, and I needed to conduct the heat out. It also, honestly, it helps cool the PC board, which is the real heatsink.
Yeah.
So most people don't know, because I've been told you designed without a heatsink. No, I have it in the biggest heatsink in the whole computer. It's called the PC board, and I can't remember, but I want to say at least 60% of the heat leaves through the PC board, through the lead frame that holds the chip, through inside the chip carrier, through the leads to the PC board.
Yeah, but PCBs are terrible heatsinks.
They are, but they're big. They're bigger than the chip typically.
They can be good at transferring if you got nice thick copper in them, but you need to take it somewhere where there is a proper heatsink.
Oh, you can. You're absolutely right. You can make the PC board into a wonderful heatsink or a heat pipe, right?
Yeah, but then you have to worry about the materials as well, because
the expansion,
Z-axis expansions is like one of the worst enemies of a digital design. When you go past 6 layers. Yeah.
So say that again. What is the enemy of you called it Z-axis expansion. Did I hear that right?
Yes, or Z-axis expansion, if you're from a Commonwealth nation like me, is one of the worst enemies of multi-layer PCB design. Is if you're using cheap FR4, you have, during lamination, it's pressed in, but during reflow, during assembly, it expands greatly and it puts a lot of pressure on the via barrels. So if you have very small vias, they can crack open in the Z-axis, or if you maybe they work fine, but if there's a lot of heating and cooling cycles in the product's life cycle, it can shorten the lifespan of the product pretty dramatically. To have, and that so you've got to, that's one of the parameters you look at when you're looking at PCB materials and you're deciding which one to use. So you want to buy, if your product has to last a long time and be reliable, it's worth investing in better materials that have a lower coefficient of expansion in the Z-axis.
Right. And I'm from the days when vias used to be inserted. They were little sleeves that got inserted into each hole. And what would happen is if here's the via and here's the pad, you could crack. Here, you'd get expansions and contractions, and eventually your pad would float free of the via barrel. And then one day we said, let's do away with via barrels. I forget what we called them, inserts.
Yeah.
Sleeves.
Spigots.
And we started blowing the solder through, doing all kinds of things as we try to learn how to. And for us, we did such mass quantity that the less solder that left with each PC board, the more money we saved. And that doesn't sound like it'd be very big. We'd save $1,000 a day, per line in solder or something. So, yeah, we stopped doing
about optimization.
Up until then, we had done 10 solder under solder mask, and you know how it gets all wrinkly and everything. And one day we said, why are we doing this? And we started doing bare copper under solder mask. But up until then, all our boards were crinkly.
Yep. And I actually remember servicing products like that and thinking, I wonder if they did this for extra current carrying capacity. And there were other products I've messed with. Like I have, it's at my parents' place, still in their basement in Sydney, an old PV Decca 528 audio power amplifier. It was a first generation Class D touring high power audio amp for PA systems. And so I was amazed at this thing because it was only one rack unit high, really small, in a small box, and it delivered 250 watts RMS per channel. Wow. into 8 ohms, and it was 528. Yeah, maximum. I think it was even you could do bridge 500 watts RMS. But the point was, like, this thing is so small and lightweight. How do they do this? And it was a Class D amplifier with a switching power supply.
I was going to ask if it was D.
But the problem was it was the first generation of those. Now everything is Class D and everything uses a switching power supply, and it's all bulletproof. And they all use really fancy topologies for power supply like CPIC or other, resonant or semi-resonant converters. So they're very low noise as far as EMI goes. Super reliable, lots of math in the design of them. But back then it was just a brute force PWM push-pull.
And they were so slow, it was hard. The devices would spend so much time outside its safe operating area between off and on. If it's in the middle, that's where the heat comes from for these devices. Class D amplifiers, by the way, are switching amplifiers. Do you want to explain Class D for us?
You can. Go ahead.
Well, they're basically on or off, and what we hear as audio comes out of it. But if you're not spending your time half on or half off, where I squared R, is the power you're dissipating. So Class A was just one linear amp. AB, oh gosh, I'm going to get in trouble here. AB was where you had two of them biased funny, right?
Well, so
that their cutoff points met just right.
So you can imagine a Class A, or maybe we do a whole episode on this sometime, but
We could.
I don't know how much our audience probably already knows most of this anyway, but
Well, that's why I'm making it up.
Class A, yes, the transistor's driving your load, usually a speaker, but maybe it's an antenna or something, right, if it's RF. But Class A,
All right.
the output devices are always conducting, and they're always in their linear region. So you get low distortion, but very low efficiency. And because they're in their linear region, they're biased on partially. So they're just like big variable resistors across a big power supply. And so they get super hot. You need a lot of heat sinking, you need cooling, and you need a big power supply. And the theoretically maximum efficiency of a Class A amplifier is 25%. So
I did know that.
For every, so that means for every 25 watts of output power to the load, you have a 100 watt power supply driving that thing and 75 watts of loss. That's a lot of heat. Doesn't sound like a lot.
It is.
When you think a modern Intel CPU is 90 to 130 watts, depending which one. But Class A amps, they sound awesome because of the linearity. They exhibit more distortion in other ways. They sound awesome, but you need big power supplies, and it's going to be a space heater for your room. So Class B got around and improved the efficiency by putting two transistors or two tubes doing push-pull, or either push-pull through a transformer or positive half cycle, negative half cycle.
Or just a circuit to balance it.
Yeah. So you have separate devices taking care of each half of your waveform. And so the problem is you get crossover distortion. As one device turns off and the other starts to turn on to take over, there's a flat spot in the middle of your waveform. And that
great way to describe it.
That introduces horrible, unpleasant harmonic content. So the way around that, so a Class B amplifier, I think, is theoretically 70% efficient or 75, but it depends on the waveform. If you're driving it to full power with a pure sine wave, the maximum theoretical efficiency is like 75 or 78%. I don't remember the math, but it's to do with the area under the sine wave versus the area over the entire, what would be a square wave for that. But to get around that crossover distortion, and you have this problem in op amps as well. Op amps often use a Class B or Class AB output stage, and there can be crossover distortion. So you need to check that when you're speccing op amps for audio.
And AB is where they biased it for minimal crossover distortion.
So at all times, both transistors are always conducting a little bit and wasting a little bit of heat, but they're biased on ready to go as soon as they take over for their half of the wave, positive or negative. So they're a bit less efficient, but lower distortion, much lower distortion. So that's a happy compromise. But then Class C, which is never used in audio, it's only used in RF output stages.
RF.
Go up to about 80% efficient, maximum theoretical, and that's a single transistor with an inductive or a tank circuit load on its collector, or if it's a MOSFET on the drain. It's so it looks like a Class A, but it's getting pulses. And the pulses turn it fully on for a moment, and then it rings and generates because it's like a pulse source for a tank circuit, and that generates a ring. So that's how carriers are often generated for RF power amplifiers.
Right.
And then that can be shaped through other means, other special RF devices that can amplitude modulate it or whatever. But that's a Class C. And then came along Class D, which is pulse width modulation. It's like a switching power supply where you have high power transistors that are either fully on or fully off, and switching at a very high frequency, and you modulate the pulse width with the audio or analog waveform, and then you filter that out with low pass filtering before it goes to the load, like the speaker, and you get, if you weight the signal with the audio response curve, like A weighting, which is it's like an oral weighting that takes into consideration the psychoacoustic interpretation of the signal by the human ear and the brain.
Human ear.
Then you get very low distortion, but theoretically 100% efficient, because the devices are never in their linear region. But of course, there's always some switching delay, so there's always some loss. So most Class D amps.
So you're saying somebody ran an FIR on the human ear there, then?
You could
to
say
use your
that.
example from last week.
You could say that. You could say that.
So somebody had to model it, but you were talking last week about using an FIR to model an amplifier.
That's right.
Right? To derive its harmonic content. Yeah. But then they do add some juju for what the human. We used to like warmth, right? We would describe an audio amplifier, and they would add some 60 cycle hum, and we go, oh, that sounds warm.
Yeah, and put the rubber hose flavor back into the hose. So it's stainless. Yes. That's the best analog I've heard for why people still like tube amps, because it's like this thing is it's like drinking through a rubber hose, and we always could taste a bit of the rubber, and it's actually imperfect. But it's what we know. It's what we're used to.
Right.
And when we finally got a stainless steel pipe that took that rubber hose flavor out, it's like having the imperfections of the dirt that the grapevines grow in affects the flavor of the wine, and we could purify the dirt and grow better grapes, but then the wine, some critics would say, I don't like this, it's too, I don't know, it doesn't have that,
it
doesn't have the distortion flavor. So yeah, the rubber hose, it's like put the flavor of the rubber hose back into this stainless steel pipe. And so so we modeled a rubber hose as far as amplifiers are concerned.
So are there class of amplifiers after D, E, F, and G?
And they're not official. They're not officially recognized or sanctioned, I think, by any industry standards body. But there's been all sorts of, there's been class Gs, class Hs, and these terms are made up by their inventors. So Yamaha, for example, came up with this technology where it was just before class D amps really took off, but they were looking for ways of reducing the size and weight of touring amplifiers. And so they came up with a class H, I think it was H, where they have two voltage power supplies. They have a high voltage supply and a medium voltage supply. And they have, instead of two sets of output devices for the class AB stage, they have four in a totem pole configuration. And for lower voltage signals, or for when the signal is beneath the medium voltage, it's only the inner pair of devices conducting. And then when the voltage peaks up higher and needs a bit more, needs more power, like when you hear a kick drum hit, the waveform goes up beyond the power supply that those main transistors, they're not switching transistors, they're class B, class AB.
Right. But they switch on. Beyond, we used to call them hybrids for that.
That's why it's called a class H. It's for hybrid. So it goes beyond their power supply. So they remain hard on, and then the transistors above them kick in and start delivering additional voltage through their emitters from the higher voltage rail. And so the problem there, again, like class AB, is you get some kind of crossover distortion whenever you're switching, whenever you're changing from one device to another. So, and they did another trick that was a little bit nasty. They built inferior, well, in our opinions at the time, they actually worked totally fine. There was nothing really wrong with it. It just made made them more complicated if anything went wrong with them to fix. But they had a power supply with these additional voltage rails, but for the higher voltage supply, they didn't have a very high powered transformer driving it. They just had a lot of bulk storage capacitance, because what they did was they analyzed music sources from concerts, live production, and they figured out the normal, at average concert volumes and at average musical tempos, what the power demands were over time. And they've realized we can have a smaller power supply but more bulk storage capacitance to drive these higher power output devices. So the energy's there when the kick drum hits on beat, but for the whole rest of that brief time between that beat and the next beat in the music, we don't need that much power.
Right.
And so they have...
I had an old Pioneer power booster that for car stereos, this is truly from the 70s. And we use terms like turbo and stuff when it would, they had an LED that would actually light up when it'd kick on that additional voltage.
That's your retro encabulator right there.
It is. I can't bring myself to throw it away. I mean, I would never use this today. It's got so much distortion.
Oh, they're horrible. Car audio is the worst. I hated those things.
And I can't throw it away. I've had it since I was like 19. So let's see, I'm 61 now. So that's a 40-year-old device.
And I really always resented the marketing around every car.
And heavy?
Every car audio product had marketing that was riddled with blatant lies. It was like, 2,000 watts PMPO. What? What does that even mean? Peak music power output.
Or they tell you the power they tell you the power consumed by the amplifier, not the power output of the.
That's right.
Yeah. And then of course there was hi-fi. I'm from the age of hi-fi. So that implies that before then it was lo-fi, and really it was all the same fi, fidelity. So, all right, hey, we're past the hour here. So we should start wrapping up, given that this is a suboptimal transmission to begin with.
Yeah. So
we still have to. So let's talk about that real quick. Would I couldn't see that Discord was useful as the video streamer itself? It's
limited to the number of connections, so I don't think we can stream on Discord. I think we keep streaming YouTube, but we need to figure out, we'll use Discord to stay in touch and hopefully build the community around this in between times, and to stay connected to friends and talk about what topics.
Can Discord get a custom URL, or does it always have to be that URL? You can't.
I don't know. I think because it's actually also an app that it's more. We just need to get the server name out.
QR code oriented.
Yeah.
Yeah. So, all right. Well, hey, my friend, good seeing you again. To everybody, I apologize. We had our normal share of tech problems. Ben, I'm probably going to roll my software back. Obviously, there's something wrong. It happened when I upgraded to do a Hackaday video, which is something I still do. So
yeah, and something else that will help. I know most successful streamers typically have a separate machine for actually gathering the streams and transmitting. So perhaps we can set up. I have enough computing power around me to set up a dedicated streaming machine that just runs XSplit. So anything else we do can be more simplified and not require too much bandwidth or processing power.
And that's why I run here. I'm talking on a machine called Video in I have a total of 20 PCs throughout this house, and I'm on Video right now. The one behind me is called NDI. It tells you what it does for a living, right?
Yeah.
So, all right. Well, let's try and ramp this down. Good seeing you, and we'll see you again next week here. Thanks, everybody.
Yep, thanks for joining us. And please do comment and join the Discord channel. So just for those,
Somebody said to post the Discord invite on the chat here.
Yeah, we'll put it in the YouTube. We'll also after the recording's done, Bill, on the video we can put some links in there and stuff. Yeah.
So I just put the Coriolis effect link in the chat. That's a web page I made that has the Discord link built into it because I'm old-fashioned DNS guy and I don't use my phone for anything except talking on it. I know there's something wrong with me, but that's all I use it for.
That's what they were invented for.
And even then I complain on it. Yeah. Actually, I use it to talk and complain about the phone on the phone. So
as if the phone can listen and make improvements to itself. Wouldn't that be cool?
Oh, it is. They're listening. They're always listening.
Hey, good to see you, Bill.
Say the word Alexa sometime. Good seeing you. Talk to you.